Welcome back for the second in our series of Demo 2 mission briefings today. This one's going to get into the specifics on this historic mission, and we will delve into the details. And here to do that for us today, we have the Commercial Crew Program Deputy Manager, Steve Stitch, NASA Demo 2 Flight Director, Zeb Scoville, and SpaceX Director of Crew Mission Management, Benji Reed. Like last time, we will start with opening remarks from each of them, but we'd also like to remind everybody, just like last time, that we'll be taking questions via phone and social media. Reporters on the phone should go ahead and press *1 to get into the queue to ask a question. You can press *2 if your question gets answered and you want to withdraw it. And audience members watching at home can send their questions in using social media and the hashtag #AskNASA. So we're going to start with those opening remarks. Let's go to Steve first.
Hey, thanks, Brandy, and good morning and good afternoon to everybody across the country. Super exciting day to be here as we're about 26 days away from our first crewed launch in the Commercial Crew Program, first launch from the U.S. In 9 years, and just an exciting day for us to get as we get ready for the flight. You know, from a big picture perspective, the flight's an important test flight of the crewed Dragon vehicle. And we've got lots of mission objectives planned, and I know Zeb's going to go through some of those. You know, one of the big things on the flight that we'll test out is the rendezvous system, which we did on Demo 1. For this flight, the crew is actually going to take over and do a little bit of manual flying as we transition up to the V-bar. They'll take some control and make sure that the spacecraft can respond to their commands. And when we get up about 150 meters from the space station, Doug Hurley and Bob Binkin will take over and do a little bit of manual flying. You know, we're going to be testing a lot of the systems on Dragon for the first time. We've got a great checkout of the whole spacecraft on Demo 1, but this time we're going to check out the life support systems, the spacesuits, the display system, and many other systems that Bob and Doug will need, and also the ability for the crew to live and work inside Dragon on the way to space station and also on the way back. You know, we're targeting right now a launch on the 27th of May. At 4:32 Eastern time. The backup launch date would be a few days later. That's what we call a flight day 2 rendezvous, which means it takes a little less than 24 hours to get to the space station. The backup opportunity would be on May 30th, a few days later. And again, that's another flight day 2 or 24-hour rendezvous, which is important for this flight. You know, one of the things that we've been working hard on for this flight is the mission management team, and the construct is a little different than what we had in Space Shuttle. The mission management team is called the Dragon Mission Management Team. It's actually led by SpaceX. NASA participates in that mission management team. I'm the NASA representative for that mission management team activity. We have been practicing over the last few months hand in hand with SpaceX through on dock simulations, through rendezvous simulations. In fact, we will have a team from JSC head down to the Launch Control Center on Monday, May 4th, and we'll do our final practice for launch with the crew, the flight control team at Hawthorne, the SpaceX control team for the Falcon, and then the NASA mission management team and SpaceX mission management team overall. I would say that's going really well. We have a strong partnership. We've established strong relationships. We've been working together for the last 2 years, and that's really what you want to see as you get close to spaceflight. And then finally, I would just want to say this is a really exciting mission for me personally. I've been working on this program for 4.5 years, and I stand here today representing thousands of people within NASA and SpaceX across the country. I can't tell you how proud I am of the entire team. They're working long hours, even under the COVID-19 precautions and virus, all across the country, all across various NASA centers, across all the SpaceX sites to make sure that this mission happens successfully and safely, and it's just an honor to be part of that team. And I'll hand it over to Zeb.
Great, thank you, Steve. So as Steve said, this is just really an exciting day, and I'm enormously proud to be here talking about the exciting launch and the mission we have coming up. You know, I think about what the world's going through now, and we're all missing our sports, our baseballs and footballs and social gatherings. This is going to be on May 27th, like getting the World Series, the Stanley Cup, the Super Bowl all rolled into one when the Falcon 9 lifts off of the coast of Florida and heads towards the International Space Station. So I just can't wait for really all of America to come out and watch what's going on in the online, come and join us, come and watch the launch and watch the rendezvous and the mission. This is going to bring it all together and get everyone to rally behind what we've put together for this show. So a couple things about the mission. After the launch happens, that's going to be a really dynamic event with a powerful launch on the F9 going up into orbit. That puts the crew in a safe orbit as they begin their rendezvous towards ISS. As Steve mentioned, that's about a 2-day rendezvous to reach the ISS. So we'll be docking on the International Space Station around the 28th. During that free flight portion, there's several tests and checkouts that we'll be doing, including some manual flying demonstrations. They'll be verifying the life support systems are working, the crew habitation within that closed loop environment that will be flying for the first time. As they approach ISS, we get into a close integrated operations sequence where the joint space station control team and the SpaceX control team works together to show and complete the final rendezvous. I actually have a video that shows that sequence for those final steps for the rendezvous. I'm happy to roll that now. Okay, here you can see the Dragon vehicle coming up underneath the space station. This is about a kilometer below ISS. It performs a series of maneuvers to fly radially around to what we call the V-bar. This is the velocity vector that the ISS is traveling in, and that will align it up on the docking axis aligned with the docking port. This video is extremely sped up, so it shows things in a much higher speed, but the graphic itself is taken from one of the training and simulation runs that we did as a joint NASA and SpaceX team practicing this rendezvous event. As Dragon approaches the V-bar here, it'll be about 220 meters away from ISS. You can see in the multiple camera views what one camera will be seeing as it looks towards ISS out of the center of the docking mechanism. At this point, the crew is going to take manual control and do a manual flight test. This will be a capability that we're demonstrating should there ever be in the future a failure of the docking mechanisms or the rendezvous mechanisms. We're able to manually pilot in the Dragon spacecraft towards the ISS and complete the docking manually. Here, the crew will be demonstrating a series of translations and maneuvers in the Y and Z axis as they really get some stick time flying the vehicle manually versus the computer automated control. As that test completes, the crew will then pause the vehicle, put it into a hold state. The flight control team will then be able to transition Dragon back into an automated approach sequence, and it will begin to resume its rendezvous towards ISS once again. As Dragon approaches ISS at about the 20-meter point, there's a built-in hold where we do our final go, no-go checks to make sure we're ready for the final docking. You can see the Dragon here holding at about 20 meters. At that point, we proceed from that hold point for the final docking sequence after that go, no-go verification has been given. At this point, this is all, again, under automated docking sequence. There's a series of navigation sensors that control Dragon to keep it perfectly aligned with the docking mechanism. And then we have the final contact and soft capture. From this point, the docking sequence continues where we achieve hard mate, and we have a series of hooks that drive to complete the final structural interface. We do a series of leak checks and repressurizations of the joint atmospheres and get the crew happily onto ISS as a joint integrated ISS crew team. The mission at that point will continue for a docked period of time. That duration, we actually have built in some variability to allow us to accommodate mission durations that best fit the needs of the ISS program as well as the commercial crew program to be able to enable the balance of the ISS needs as well as the development and readiness for the crew on mission beyond that. During the docked time frame, there's going to be a series of test objectives we're going to be doing on the ISS. This is really to shake down and demonstrate that all of the preparations and the emergency capabilities we have built into this vehicle have made it reliable as a lifeboat in a contingency aboard ISS, and it's always there as a backup to be able to get the crew members down to the ground if needed, but also as a reliable place to ferry the crew members up and down on a regular and repeatable basis. At the end of the docked sequence, we'll have a series of events we'll do to prepare for the undock. This is going to be transferring some hardware back onto Dragon, removing stuff off of Dragon, putting it back onto ISS. Then we'll begin the undock preparations. This will again be an automated undock. The crew will depart station and have about a 2-day free flight sequence before splashing down safely off the coast of Florida. At that point, the recovery operations led by SpaceX will begin. They'll get them on the recovery boats and bring them back safely to the Florida coast to hand back off to NASA. I just want to say that from an overall mission perspective, this is really going to be an exciting day, and we're looking forward to a very successful mission. There's been a tremendous effort with the teamwork between SpaceX and NASA as really a joint integrated team to bring us to this point. With that, I'd like to hand it back over to Benji.
Hi there. Thank you so much for having me on today. As Steve mentioned earlier, we're really here representing thousands of people here at SpaceX, thousands of our partners at NASA, and all of our suppliers and vendors, and of course, the American public and the public around the world. Everybody's super excited about this. We're honored to be a part of this. It's a historic event, and also it's a sacred honor to make sure that we are going to bring the crew, take the crew up to space, bring them to the space station safely, bring them back home to their families. Fundamentally, this is what SpaceX was founded for. Our goal is to take people to space, to make life multiplanetary. And so this is an historic event for our company as well. We are closer than ever now as we get ready to bring human spaceflight capability back to the United States for the first time since 2011, since the space shuttle was retired. And as we've heard earlier today too, the criticality of this is not just that capability, but to actually help the space station stay fully operational, and to help not only our space program, but the program of programs of many countries around the world who are involved in the space station, and many countries who look forward to being involved as part of the space station. Really, this endeavor is the culmination of not only years and years of experience or of time and work, but hundreds of thousands of hours of tireless effort to bring us here. And it's all focused again on the safety and reliability of the system. And when we talk about the system, it's important to understand a lot of times we focus on Crew Dragon, which of course is kind of the crown jewel and what carries the astronauts. But there's really a whole system that runs, from the engineers and designs and analysis that goes on through the factory and fabrication and all the testing. It involves the Falcon 9 launch vehicle, the Dragon spacecraft, the operational teams and all the operational centers, and of course, it's hardware and software and everything else that we put together. All of this has to be done correctly, has to be done well, super vetted with our partners at NASA. We're very grateful for their input and support, and how we all work together to ensure that reliability will be in place is critical. And so we're excited, very excited to be here. I think we're all very appropriately nervous and getting more so as we get close to this day. We're at 26 days from launch, and it's going to be quite a show. I think that it's important, and I talk about some of the tests and some of the things that we've done. I've talked about there's a lot of these hours that we've put in. Well, we've spent over 700 tests of the Super Draco system. The Super Dracos are the engines on Dragon that are used to carry Dragon away from the Falcon in case there's an emergency need to escape Dragon from away from there. There's been thousands of tests on the Draco engines themselves. Today, we're actually hoping to complete the 27th test of our Mark III parachute system, one of the most advanced parachute systems in the world, and probably the most advanced space orbital return parachute system. in the world and ever made. It's very exciting. We've actually performed over 80 tests of parachute systems for Crew Dragon, and then many, many more for all of our parachute systems, including the ones that flew on Cargo Dragon under the CRS program. On that note, we've flown Dragon to and from the space station successfully 20 times for cargo missions, and of course, last year we had our Demonstration 1 mission, which was the Crew Dragon without any crew on board, and it went to the space station and we did some tests there. You know, they opened up the hatch and then came back home, landed beautifully. The whole that whole process was kind of from start to finish just exactly the way we wanted it to be. We learned a lot from the flight, and it's very important and exciting that we were able to do that before we fly Bob and Doug. As we move forward from that test flight, we then did another very important test flight, which is the in-flight abort test. We did that back in January of this year. And that was actually a follow-up test from a pad abort test that we did a number of years ago, 5 years ago. In both cases, it's where in the pad abort case, we have Dragon on the pad, and we test that launch escape system to ensure that in case something goes wrong on the pad, we can escape the crew rapidly away from the pad and land them safely in the water. And in January, we did the same thing in, I think, what was probably one of the most complex engineering tests ever done, maybe in the history of the world. I don't know, but it was amazing to see. We actually put Dragon on top of Falcon, launch the Falcon, and then initiate the launch escape system, kind of at this peak moment of loads on the vehicle. And again, we demonstrated that Dragon is capable of carrying the crew away from Falcon in the event of an emergency. These tests are critical steps on the way to this upcoming Demonstration 2 flight. You know, this is also a test mission. I think in an earlier briefing, Administrator Bridenstine made a point, which is something I hadn't realized beforehand, which is this will be only the 5th time in the history of the United States, and I think the 9th time in the history of the world, that that humans have flown on a brand new space system, space flight system, and that's a big deal. That's really, really cool. And again, it's an honor and a sacred honor that I know that all of us here at SpaceX and all of our partners that we've been working closely with at NASA take very seriously, and we're excited to be a part of it. As part of that effort, we have been working closely with the crew and all of our operations teams. They put in thousands of hours, literally thousands of hours of training and simulation time, and at least a couple of thousand just directly with Bob and Doug involved in the loop. And I think we have a video that we want to bring up and talk a little bit more about what's going to happen as part of the training that we've done, and also what's going to happen on the day of the launch. We can bring that video up now. You can see, as you've seen on some of this video, there's Bob Bankin and Doug Hurley, who are our astronauts who will be flying with us on this demonstration mission. They have jointly executed many simulations, like I said, a couple of thousands of hours of worth of training and simulation time, and have been working closely together and with our team on all of this. We are looking forward to actually the day of the launch itself. On that day, it'll be on at about 4:32 p.m. Eastern time. We'll launch the crew. A few days prior to that, we'll have done a series of what we call, first of all, our static fire test. That's where we have Dragon and Falcon integrated and standing on the pad. We hold the vehicle down as we initiate the Falcon engines. And make sure that basically do a quick check of all the systems, make sure everything's looking great. We're also going to do what we call a crew dry dress rehearsal, where Bob and Doug will get into their suits at the ONC building at NASA, and they will get ready to get into the vehicles, come to the pad, go across the pad arm, The pad crew will be there supporting them as they get into the Dragon, and they'll get into their seats. The Dragon will get closed up, and they'll get all in place. And so we'll basically run that whole sequence up to the point of where we were going to launch. We'll do that as what we call the crew dry dress rehearsal. And then on the day of the launch itself, the process is the same. We'll have practiced it in the rehearsal about 4 hours before launch. The crew will get ready to go. About 3 hours before launch, they'll be getting transported to the pad, and then we get ready to go through the launch process. And from there, it's a lot of the similar kind of thing that we do normally for launches. You know, the goal of our systems are always to have you know, Dragons fly and Falcons fly as consistently and repeatably as possible, whether we're flying crew or not, and that adds a lot to the safety and reliability of the system. And I think that we have an infographic that we're going to be bringing up that talks a little bit about what it looks like after we launch. And you can kind of get a sense here if you look at this infographic as to what it looks like from launch and what the series of events are going to be. I think that probably kind of some of the key takeaways from this are going to be that we have, you know, once in orbit, the crew is going to be taking and doing a number of tests and various demonstrations that they're going to be doing in the system, the things that they can control, and things that we need to check out in terms of the life support system and other things that they'll be looking at in there. I think that we have another infographic that we'll be bringing up. This is talking about as we approach Space Station, and you saw Zeb's video earlier that gave you another view of how that looks as Dragon approaches Space Station and gets ready to dock. And then there's one more graphic that I think we'll be bringing up, and this is for return. And just talk a little bit about this in a little bit more detail. So Dragon will be departing from Space Station, and again, similar to the approach, Dragon is fully autonomous, and the crew will be able to take control to do manual piloting if needed in an emergency situation, but otherwise it's fully autonomous. And as Dragon leaves Space Station, it'll get ready for its re-entry. Of course, it'll jettison the trunk, as we always have done with the cargo Dragons, as we did for the demonstration 1 flight last year. And then it'll come home, re-enter, and deploy the parachute system, the same parachute system that I mentioned. We're going to be doing our 27th and final test of the Mark III design today, and as we deployed for the demonstration 1 mission last year. And so once the crew is returned to the water safely, in less than an hour, our recovery forces will actually have acquired the Dragon and brought it up onto the recovery vessel, and we'll have the crew out of the Dragon. All of that in less than an hour after splashdown. That really wraps up what the whole mission looks like, and from there, I think I'll hand it back over to Steve.
Yeah.
This is Brandy. I can take it from here. We're going to go next to some questions. So again, press *1 on the phone to let us know if you have one, and on social media using you can use the hashtag #AskNASA. Our first question is going to be from Lauren Grush with The Verge. And Lauren, please remember to direct your question to the person you'd like to answer it.
Great. Thank you so much for taking my question. I think this is for Steve. I'm really curious to hear more about the extended mission. When was the decision made to make this an extended mission? How did that change the training for the astronauts? How long will they be staying? When do they come home? What will they be doing? Just more info about that would be great. Thank you so much.
Okay, good question, Lauren. So we made a decision to have this capability to fly a longer mission. It was probably about 6 months ago or so when we started talking about it, Lauren. And the vehicle has the capability to fly pre-mission. Our predictions are about 119 days, and that's based on the solar arrays. The atmosphere degrades all solar arrays in low Earth orbit over time. And so the solar arrays on Dragon, we'll watch them carefully to see. The idea behind it was we started looking at when we might be flying this mission, and the needs of the space station program, and there was a bit of a need to have Bob and Doug augment the capability of station. So we looked very carefully at all the vehicle systems at the time. This Dragon vehicle is designed, except for the solar arrays and a few other components, to meet that typical 210-day mission requirement for us. And so we decided, hey, it's smart to go ahead and extend the mission and have Bob and Doug be on station a little longer. Bob and Doug did get additional training, and Kirk may have talked about it already earlier today, but they got some additional training on the space station systems. In fact, Bob went in and did even a few neutral buoyancy lab runs to practice for spacewalks, so they can help augment the station crew. When we get on orbit, we'll again look at the vehicle systems and how it's performing, how Dragon's doing. We'll be looking also at the readiness for the Crew 1 mission later this year. And then at a time during the mission, we'll decide exactly how long we'll fly the mission.
Okay, next we'll take a question from Mark and Vingo, who is with the SpaceX Reddit group. Martin, can you hear us?
Yes, hello. Can you hear me?
Yes.
I have a question for Benji. What are the differences in the launch criteria between normal cargo launches, weather, etc., and manned launches? Do you anticipate a higher risk for weather-related scrubs? And will there be any impact on the recycle time between launch attempts? Thank you.
Understood. That's a great question. And certainly we do expect a higher risk of weather-related scrubs on this mission. You know, when you're doing a standard Falcon flight, you have all of the launch criteria that you look for being able to launch a Falcon. When you add Dragon into that mix, there's an additional set of launch criteria that you worry about that are particularly weather-related. And then with the crew especially, we need to think about, in the case of an emergency, if they needed to bring the Dragon home, you know, either in a launch escape scenario from coming off of Falcon, or even after Dragon is on orbit and it needs to come home very early in the mission cycle. We need to think about the weather along the track of where Dragon could come back down as well. And so we actually are looking across not just the local weather or even the getting to orbit weather, but also where Dragon would need to come back home. And so the combination of all of those constraints put together, certainly I would expect there to be a very high chance of scrub due to weather. And given the time of year, it wouldn't surprise me as well for that.
Our next question is going to be from Mark Mancini with How Stuff Works.
Hello there. I believe this question is for Zeb. I was wondering if you could speak to the space suits that are going to be worn on this mission and whether or not SpaceX was involved in their design.
Yeah, this is something that Benji can speak to very well as well. This is an entirely SpaceX-developed suit, and it's designed to protect the crew members in case of loss of atmospheric pressure. So it's a full pressure suit that they wear during the ascent portion. We also have the crew members don it and do leak checks prior to the docking and the undocking, then eventually the re-entry. But this was entirely a new build, new design by the SpaceX company.
Okay, next up we will take a question from Kenneth Chang with the New York Times.
Hi, thank you for taking my question. So this is from Mr. Reed. I was wondering, after the certification work is done, what happens to this Crew Dragon? Is it going to be used for an Axiom flight?
Great, that's a good question too. You know, Dragon has been designed for reuse and reflight up to 5 times, similar to our Falcon vehicles. Not only do we refly Falcons for many missions, but we also refly Dragons already. The Dragon 1 line for cargo under CRS has a number of those have flown more than once and even more than twice to the space station. We intend for Crew Dragons to also be able to be fully reusable. And this Dragon itself will be brought home and refurbished and made ready for a future flight. I can't speak to exactly which flight it'll fly on. You know, we're always assessing our manifest and based on schedule and readiness and what timeline meets for our customers. But certainly all of the Crew Dragons, our intent is to refurbish them and be able to refly them.
Thank you. Next, we are going to go to Daniel Oberhaus with Wired.
Hi, yes. I just had a quick follow-up about the solar arrays. Can you tell me, Steve, a little bit about what specifically limits Dragon's time on orbit relative to the solar panels? And I was hoping, Benji, you could also tell me how the manual control on Dragon differs from that in Soyuz, because it's quite a unique control panel from what I can tell.
Yeah, I'll start with the solar arrays and then let Benji talk about the manual piloting capability with the new touchscreen displays. The solar arrays themselves, any solar array in low Earth orbit tends to degrade a little bit over time. It turns out the atmosphere has a little bit of oxygen in it. It's called atomic oxygen. And so there's a little bit of degradation in the ability for that solar array the cells itself to generate power. And the particular cells on the trunk of Dragon, based on analysis capability, kind of a worst case prediction, we think we can get about 120 days capability out of those. What we'll do in flight is we have this curve of what we expect that degradation to be over time, and we can kind of look at the power that the arrays generate each day and kind of plot that against this prediction, and that can give us the overall total capability. So that's really what's going on with the solar arrays. We looked at the rest of the vehicle. We don't see any other life limiters. We looked at the pumps on the thermal system. We looked at the propulsion system, all the other components. When we talked about extending the mission, and the solar arrays are the only one really that has a little bit of a poke out. And so we'll just kind of watch their performance in flight and be able to make a good decision about how long to stay docked. And I'll let Benji talk about the touch screens.
Sure, absolutely. You know, Crew Dragon is a 21st century spacecraft, and we wanted it to not only you know, be as safe and reliable and as you'd expect from you know, the most advanced spacecraft in the world, and to be one of, if not the most safe spacecraft in the world. But we also wanted to look amazing and look beautiful. I mean, spacecraft and spaceflight should be inspiring. We need to be excited about moving into space, and I think the Dragon design does that, and certainly the look of the control system does that. But more importantly, the control system is technologically a modern feat of engineering, and it relies on many different systems that exist for touchscreens that we use all the time now in our lives and in industry. And so one of the biggest differences that you see, of course, is that, you know, from a traditional cockpit, you know, designed many decades ago, where you have many switches and knobs and dials, inside of Dragon you have these large touch screens that allow you to do most of the data reviewing and all of the data reviewing and all of the information that you gather from the vehicle, and also quite a bit of the control. There are a few actual manual switches or knobs that you need just in case of emergency or convenience, but otherwise it's all touchscreen controlled. And the crew, of course, has put in many hours practicing and using those systems for getting ready for flight. Again, Dragon will be fully autonomous. The expectation is that it can carry the crew safely to the station and bring them home without direct intervention. But of course, we want to make sure that we give the crew all the tools possible in case they need to manually pilot or manage Dragon's flight. And so they're able to do that.
Okay, we're going to take a couple questions from social media now. I think this one will be for Benji as well. Trevor from Twitter is asking, who will the Capcom be for the DM2 mission? And I know that's a little different than we usually do it.
That's a great question. And actually, I'm going to throw that one back over to Zeb, because his team, he can talk a little bit more about what Capcom is for folks who may not know what that is, and then also a little bit about how we're integrating with our team and the NASA team.
Yeah, so there's a new capability that differentiates the Crew Dragon vehicle from previous Dragons, in that with the crew on board, they now need the communicators on the ground to support them. And so the Capcom role itself goes back to the old Mercury days, with the capsule communicator was always an astronaut that would be able to talk to the crew and share the perspective of the ground, and be able to tie the onboard crew with the ground team as well. We still have the Capcom position flying the International Space Station every day, and we'll continue to have a specified Capcom lead for the upcoming Demo 2 mission on the NASA side. New to this mission, SpaceX has a corollary position. They're calling it Core. And the Core is the individuals responsible for talking to the crew members throughout the mission. And so they have a team of cores, which I have trained on all the various phases of the flight. And so there's a core supporting for the ascent phase, a different one during the rendezvous and docking phase, and then another one during the undocking and splashdown phase. All the core team has been trained well to be able to cross-train to support other phases of flight. And we've been working closely with them to make sure that we're sharing our experience and learning from each other, to make sure that we're providing the crews the information they need, both in the nominal mission and in the contingency cases as well, should they arise.
Thank you, Zeb. We're going to try again for one for Benji. This is coming in actually from a lot of people on many different platforms, wanting more details on the spacesuits. They want to know more about their features, when they're used, what they're made of, and are they comfortable?
So the spacesuits are, again, another piece of the important equipment, and really a subsystem of the vehicle that is critical for crew safety. Fundamentally, we call these flight suits. As I think Zeb mentioned earlier, these are not the suits that you see people using outside for what you call extravehicular activity. These are suits that are designed to keep you safe while you're still in the vehicle, in case there's a loss of atmosphere. Or something else is happening inside the crew, inside the vehicle, where you need to ensure that the crew has the right amount of atmospheric pressure or temperature, oxygen supply, those sorts of things, and that's what the suit is for. The suit is a one-piece suit essentially. We looked at a lot of the different kinds of things in previous flight suits. And tried to make some of the adjustments that we thought we could to really make this an advanced flight suit, as advanced as possible. Some of those things include the fact that it is one piece, so that you don't have pieces of your suit kind of floating away, a glove floating off and getting lost, that sort of thing. And then you use the suit again, as mentioned, during kind of these critical phases of flight. We want to make sure that kind of where your highest risk, or maybe something you might need to control for in the atmosphere, they've got their suits on and ready to go. So of course that includes launch. And then when you're on orbit, they'll actually do some practice with the suits as well. As you're approaching space station, getting ready to dock, they'll have the suits on, and again, they'll put them on as they undock, and when they come home, when they're coming home for splashdown, they'll have the suits on. The suits provide air, oxygen supply. They maintain pressure. They'll maintain the right temperature for the crew. The suits also have an integrated communication system, so that the crew can communicate through their helmets as they have their helmets on. And the suit really is an integrated system of Dragon. It plugs into the seat. When you're sitting in your seat with your suit on, you actually plug in. And similar to flight suits in past systems, that does the same thing. And when the crew is not in Dragon and they have their suits on, they also have they can plug into a device that they carry. The suits are really kind of two major layers. There's what we call the bladder layer, and that's the layer that does the containment of atmosphere and pressure. And then there's the outer layer, and that outer garment kind of really serves two purposes, of course, or three purposes really. It holds the whole suit together. It's a fire-resistant layer as well, to keep the crew safe in the case of fire emergency. And then, of course, it looks cool. And again, just like the interior of Dragon, it's important that the suits are comfortable and also are inspiring. As we see the astronauts walk out to the pad and be in their vehicle and do everything that they do in the suits. It's something that we want to make sure is very inspiring as well. But above all, it's designed to keep the crew safe.
Absolutely. We're going to go back to the phone bridge now and take a question from Mike Brown with Inverse.
Hi, sorry. My question is for Benji. I would like to know, in terms of the spacesuit, how much of the design will help inform future missions, like the Gulliver manned mission on Mars? How much modification would it require before supporting these sort of missions, and will it serve as the basis for these sort of future missions?
Sure. The suits themselves are designed particularly for use within Dragon, and as our focus on transporting NASA crew to and from the space station. So that's our number one focus for the suits today. But just like all systems on Dragon and Falcon and everything else that we do here, we've designed and developed them based on knowledge of all the past systems that have been developed and designed by others. And then we take the designs and results of our work and the data that we get from test and actual flight to feed into future work. So as we look towards the future, certainly we'll be taking what we learned from these suits and getting the data from it and applying that for future missions.
Next up, we're going to go to Marina Corin from The Atlantic.
Hi, everyone. Hope you're well. This is a question for Steve. Could you please talk a little bit more in detail about the specific precautions that NASA employees are going to be taking as they prepare for the launch? For example, on the day of the launch, will you be advising people in the control room at Cape Canaveral and other sites to be staying 6 feet apart and to wear face masks?
Yeah, good question. Obviously, with the COVID-19 pandemic, we are taking extra precautions for all the teams supporting the launch and all phases of flight. So in the various control rooms, we've laid out those rooms to have at least 6 feet between anybody on a console looking at displays. We go in and clean those rooms ahead of time with sanitizer and make sure that they're sterile. We have hand sanitizer available for all the employees, and I know Benji and the SpaceX team are taking all the same precautions. We have masks available for those employees. So we're going through all those precautions that anybody would do with the virus. And then in between shifts, we make sure we clean things for the next individual group of flight controllers and operators. And they're doing the same thing in the Mission Control Center. Zeb could talk more about that. And I know Benji and the SpaceX team are doing the same thing. Any crew training, there's been a lot of precautions taken as well for any individual that needs to get close to the crew, various medical checks to make sure that they're well and healthy, and the appropriate mask, gloves, and so forth. So we've been taking those precautions. We've been practicing those. Actually, we'll practice with this launch simulation that we're going to do on May 4th. On Monday, we're going to go through and use all those precautions. And we did a sim back in mid-April where we used those precautions as well for all of our employees. And even we have some employees that can support remotely based on the modern technology capability that we have. So, so far it's worked well, and we don't really see any impacts to how we're going to operate on launch day or rendezvous day or any other part of the flight.
Now we're going to go to Charles Fishman, who is with Fast Company.
Hi, thank you guys so much for doing this. A quick follow-up on the spacesuits and then a spaceship question. Somebody said in passing that SpaceX had designed the spacesuits. All the spacesuits that U.S. astronauts have used since Apollo have been made by ILC Dover in Delaware. Did SpaceX, A, consult them, and did SpaceX build these suits or manufacture the suits themselves? And Benji, on the spaceship itself, you talked a little bit about the touch controls, but give us a little more sense of the spaceship as a spaceship. It really is the first spaceship design in 40 years in the United States. A lot has changed since Shuttle. how did things like life support, the way the spaceship maneuvers, the way it navigates? Does this ship use inertial navigation? Does it rely on the network of GPS satellites? Tell us a little bit about what was interesting in taking a clean sheet of paper and designing an all-new spaceship in a completely different era. So space and spaceship.
Sure. Understood. So I think number one, in terms of the spacesuits, I can't really say exactly who specifically we may have consulted or not. I know that we worked very closely with NASA, and we also relied, again, on the many years of spacesuit design experience and practice, from around the world. And we did build the spacesuits here in-house. Just like many things, we outsource many of our components and piece parts. We have, actually thousands of vendors and suppliers that we're honored to have supporting us here at SpaceX. But we do the integration work. We actually have a great team of soft goods personnel, engineers and technicians who are busy working all the time building the various what we call soft goods for the vehicle and for the systems, including the spacesuits. And it's been an exciting journey as well. As much as everything else, watching the spacesuit design evolve and get tested. A huge amount of feedback from the crew directly, Bob and Doug. And even some of the other astronauts from the crew office have been directly involved for a number of years in our spacesuit design and giving us feedback in terms of comfort and performance and mobility. And that's been a great partnership to see that come together. In terms of the spacecraft itself, maybe just a little bit more of an overview, give you a sense of it. There's 4 seats in this version of Crew Dragon. They go across in a row. There's some windows that people can look out of as they're flying, and also as they approach the space station, see the Earth and also see the station. There is the touchscreen panels that I talked about. Those are basically when you're seated in the center 2 seats for the pilot and commander, you'll look up and you can touch those touchscreens and see them there. Below the seats is our pallets, what we call pallets, where we can put in cargo. And we will be carrying cargo on this mission. We carried cargo on the last mission, the Demonstration 1 mission. We'll be carrying cargo on Demo 2 for the space station. That's very critical to have the staff and people leading and running and managing the space station, but also they need all the stuff to do that. Not only just food and water and supplies, but the experiments and the science. And Crew Dragon, similar to Cargo Dragon, will be able to carry powered lockers or powered basically freezers and refrigerator units that are specially designed to carry certain life science and other experiments that go up on Dragon. That a lot of those are time critical and temperature critical, and so we'll be carrying those as well in that cargo area on Crew Dragon. As well as the cargo area, there's just a ton of little cubbies and places where people put different things. There's crew supplies, of course, food and water, and then also personal supplies that the crew can bring up, their personal belongings. They have a stowage for that. Dragon, as it functions, is building again on decades of heritage for the capsule type spacecraft. And of course our many missions and many years on the cargo resupply vehicle, the Dragon 1 line, and which has flown many times. And similar to Dragon 1, Crew Dragon has the Draco thrusters, and that's our primary control for moving around in space when you're on orbit. As I mentioned, Crew Dragon also has the Super Dracos for the launch escape system. Those are some of the key aspects of Dragon. There is a nose cone. A cool thing about Crew Dragon and Dragon 2 in general is that the nose cone actually it opens for docking, and then when we undock, it actually closes and returns. It's not jettisoned. We'll come home with the nose cone as well and fully reusable there.
Okay, we've got about 10 minutes left, so if you can limit your questions to just one part, that will help us get through more of the request. Next up, we're going to go to Alan Boyle at GeekWire.
Hi, thank you for taking my question. I wanted to ask about the time frame for extended mission. You've talked about 119 days as perhaps being the maximum. Can you tell me what the minimum versus the maximum are, and what the decision timeline might be? Thank you.
Yeah, I'll address that question. So the minimum mission duration is really about a month, and the maximum, as I talked about, is 119 days. And we're really, again, trying to do both a test flight with this vehicle and also have the vehicle dock to station to allow Bob and Doug to augment the station crew. And really the decision point is, hey, is Dragon healthy? Is the vehicle performing well? The Dragon that's on orbit, and then we'll be looking ahead to that next mission, the Crew 1 flight, and looking at the vehicle readiness and trying to determine, hey, what's the smart thing to do relative to the mission duration. So again, it's a little bit of a variable, but it's one that I think we can manage well. And we've been talking to the space station program about this and the commercial crew program in SpaceX, and I think we're all on the same page. Is we would like to fly a mission that is as long as we need to for a test flight, but also support some of the space station program needs and augment their crew capability to do science and other operations at station. You know, once we're docked, the risk, you know, if you look at the risk in spaceflight, the risk in general is two big parts. It's the launch phase and then the landing phase. And so once we're docked to space station, we can wake the Dragon up once a week and check the systems out and make sure everything's healthy, and then look at the solar array performance and then decide when to return.
All right, thank you. Next, we're going to go to Ivan Caron from AFP.
Thank you very much. A question for Steve Stich and Benji Reed. How many people from the NASA and the SpaceX teams have had COVID-19 or have been in quarantine so far, if any?
Boy, I would not know that. I would not be able to tell that data from a NASA perspective. I know we have had employees and contractor employees with COVID-19. I really wouldn't know that number.
We can check on that and get back to you on that question, Ivan. Let's go now to Andrea Leinfelder from the Houston Chronicle.
Hi. I just wanted to get a little more information on when it's going to be manually controlled and when it's going to be automated when you're like docking with the space station. And also, sorry, if you could clarify how many days it will take to get there and to land. Thank you.
Andrea, thank you. I can take that question pretty well. The time to get from the launch to docking is a little bit variable. For the May-June timeframe, we're looking at about a 2-day rendezvous. It's actually about 19 hours to be able to get there. But as the space station is moving around the Earth, the distance and the what we call the phase angle between that and the Cape in Florida is variable. And so the Dragon has the capability to get to space station a little bit faster. They can even get there on a 1-day mission, or in some cases a 3-day rendezvous profile. And that just will be variable based upon the particular day that we choose to launch. And the same is true coming down as well, that time to get the crew down. We're trying to hit a very specific point off the coast of the Florida and the Atlantic. And so that time will vary based upon the trajectory of the ISS and the Dragon as it comes down. In terms of the manual time periods versus the automatic time periods, there are two periods, as I mentioned, that are planned for manual control. One is early on flight day 1, after the vehicle has launched and they've done the initial activations and checkouts. There is a period where the Dragon is essentially coasting as it tries to catch up with the space station. During that time, we expect there to be an opportunity to do this first part of the manual flying demonstration. There'll be a demonstration of the attitude control, so roll, pitch, yaw, making sure that those are working, but it's not actually going to be changing the trajectory of the Dragon itself. It's really just orientation tests. And then the second time, and from that point, it'll continue its automated approach with the burns programmed both by the vehicle and by the ground controllers. As it gets closer to ISS and it's within that 170 to 220 meters or so from the space station, there'll be the other manual flight test that is performed by the crew flying. And then those are really the only planned times. As we said, the crew has the capability to take over really and decide their own fate if that was necessary to be able to perform a manual reentry, splashdown. They have a lot of capabilities we've vigorously tested with all the systems from guidance, navigation, control, reentry, parachute deployments, and so forth.
Next up, we'll go to Leah Crane with New Scientist. Leah, are you there?
I apologize. Hello, can you hear me?
We can. Go ahead.
Okay, great. Hi, thank you for doing this. I apologize that I have another corona question, which is how will the astronauts themselves be protected from infecting the ISS? Will they be quarantined for an extended period of time before the launch?
Yeah, I can take that question. So we've been going through a number of precautions with Bob and Doug as the coronavirus pandemic has been in place for a few months. You know, we have sort of minimized contact with them for weeks now to ensure that they have less contact than most people would. They only come to certain training events where they really need to be present. A lot of training events are done virtually. And then the number of people at a particular training event is dramatically minimized. And then people in close proximity to Bob and Doug, you know, have masks and gloves and to protect Bob and Doug. And also they are screened from a health perspective. They will go into a quarantine for flight. Right now, I think for May 27th, that quarantine starts around May 16th. They would come on site here at JSC and be in the crew quarters facility, and then they'll fly down on a NASA aircraft and be quarantined down at the Kennedy Space Center, just like we did for Space Shuttle and other launches. So we've got a robust plan in place to protect Bob and Doug and ensure they're healthy when they go fly, and also that we protect the space station crew members as well.
Okay, we're going to take a question next from Joey Roulette from Reuters.
Hey, thanks so much for doing this. Question for all. After Starliner had its 5-minute blackout with the TDRS satellite network during its OFT, has the Crew Dragon teams taken any steps to prevent the same type of blackout from occurring? And then also for Steve, the specific mission duration is, you know, based on the readiness of the next commercial crew launch. And I was wondering if it's also based on any other factors, and if so, what are those factors? Thanks.
Yeah, I mean, I can talk a little bit about the OFT flight and the TDRS outage. That particular mission, the reason that we had a TDRS outage was really not necessarily a network problem. It wasn't a problem with the TDRS satellites or the network. It was really a problem with the time on board the Starliner spacecraft and that time being off. And so Starliner really wasn't looking for the TDRS satellite in the right location. So we've done enormous amount of testing with the Dragon to make sure that the Dragon spacecraft and the Falcon 9 launch vehicle don't have any of those problems. In fact, the SpaceX team has done extra tests after that OFT mission. So we know that the Dragon spacecraft knows how to find TDRS. In fact, it did that on the Demonstration 1 mission back in March. So we don't really have any concerns there. And then what was the second part of your question?
Second part was whether the mission duration of Crew Dragon is based on any other factors other than the timing of the next commercial crew launch.
No, really, again, it's based on two things. Is the spacecraft healthy? Is it doing well? Do we see any problems that we should return early based on how the spacecraft, the Dragon's performing? And then the second one really is when is that next flight ready so we can really have our first full up crew rotation mission where we have 4 crew members coming up on Crew 1 and go up to the full operational capability of Dragon. So it's really based on those two things.
We are once again out of time. Thanks so much to our briefers and everyone who called in or sent in questions. We'll wrap up this briefing now, but again, you can stick around. Our final briefing of the day is coming up at 1 p.m. Central, 2 p.m. Eastern, when we'll have Demo 2 crew members, Robert Benkin and Douglas Hurley, here to answer your questions. We'll see you then. Thanks.